Okay.
Yes, thank you, Mr. Iliou, for what you present to us about your experience of solving many challenges in the PV systems installations and maintenance. And now we reach the questions for our friends who are attending with us. We'll start with the first one. Please, guys, for the questions, we only have 30 minutes, and we hope you have your questions ready and in short terms. And also, Andreas, Iliou try to answer them as quick as he can, so we can take as many as we can of the questions. Let's go with Mr. Iliou. Mr. Iliou, I hope you can, yes. Go ahead.
Yes, I can hear you clearly. First of all, thank you for this forum. I only have one question. In systems where you deal with, let's say, a hybrid system, you have both the DC side and the AC side. When you're doing your earthing, do you do them separately, or like you earth the AC side separately from the DC, or you can combine the earthing?
You mean, yeah, you mean on a roof or free?
Yes.
On a roof system, or on any
system where you are dealing with both AC currents and DC currents. Do you do the earthing differently, or you can use the rod?
I do the earthing. For example, if you see the picture still, that's the yellow is the inverter. So the earthing is combined with the modules, with the steel structure, with the rail structure, or with the hookup of the panels, and then it goes to the inverter, and from the inverter it goes to the transformer. So all the earthing is combined to each other. Does that answer your question?
Thank you, because I've faced such a situation before, and someone was telling me we can have cases of leakages on the AC side that can affect the DC side if you combine the earthing.
Yeah, but it depends also. I mean, I was also in Vietnam. They said to me AC and DC must be separated, and then they put two earth spikes 1 meter next to each other. So there's no way the earth from AC says, oh, I'm going to stay at my side, and the DC says, I'm going to stay on my side. If it's 1 meter next to each other, they will combine at the soil if it's wet. So the problem is more with the inverter is also shoveling some leakage current into the modules. So if you have a problem with transients, if he has a problem with surges, actually he's feeding also the modules. You can measure AC current at the modules. So for me, it's very easy because you can look, for example, if you mount, I mean, I don't know your installations, but if you mount the modules and the inverter at the same structure, you already earth them together, because the modules, the structure, and the inverter, when they're hooked up next to each other, they're already earthed via the rails. So it's much better to have an earth connection. And if you face some local laws, I know that they exist, but like I said, if the modules, the light, for example, also there is a rule in Germany, lightning connection points, when they are within 0.5 to 1 meter of the modules, you have to align the lightning structure towards the existing earthing structure. So I hope that helps a bit, because if you separate them, it's not going to help you in problems like surge arresters.
Okay, thank you.
Thank you. Thank you, Mr. Iliou. Now we'll go to the Mushir. Mushir Muhammad.
Hi.
Hi.
How are you?
Good.
Hello, everyone. I have two questions, and I would like it if you could help me out, please. I need to know, in your option, what is the most efficiency PV panel configuration between distributed panel with power electronic panel level or centralized panel with only one inverter? What is the typical usage in the market right now and why? That's question.
Did you get it, Mr. Iliou?
I did not exactly understood. Can you?
He's asking about the central inverter. I
Central
think.
gate inverter.
Yeah. What is better? Is the string inverter or the central inverter? I think.
Yeah, there is a lot of stories now. Central grid inverter, they're mostly more economically viable in the old days. Now not anymore that much. And the output of multi-string inverters is much better than central grid inverters. When you have a 1 megawatt field, and also it's quite challenging because you never have similar cable lengths. Actual fact, normally you're not allowed to combine different lengths of cabling towards combiner boxes and then towards central grid inverter. But that's on its own already a mistake saying that, because you would never install a system, because most of the lengths are between 250 meters in between towards the combiner boxes, and then you go with the main DC cabling. It's sometimes a design issue. For rooftops, I would only go for multi-string. For free field, it's debatable because, like I said, they are on the return of investment sometimes cheaper, but depends also on the contracts. But from the output, a multi-string inverter is always better than a central grid inverter.
Okay, Mr. Mushir, I hope this answers your questions.
Thank you, Mr. Iliou, and you.
Thank you.
Thank you.
You're welcome.
Now we'll go to the Mr. Darius. Darius, he's from Poland and he's working in Kuwait as a PV solar manager. Hi, Darius. Darius, are you there? Guys, if you are not ready, we have to go to the next one. Now we'll go.
Hello, I'm here.
Yes, hi, Darius.
Hi, Andreas. How are you?
I'm good, and you?
Yeah, enjoying Poland in wintertime.
Very good.
While Kuwait is closed.
Enjoying PV in Poland, you must say.
You know, I never seen, you know, when the snow comes, that the melting of the snow is not that easy part, you know, so a couple of days or even weeks they stay under the snow, especially when there is frost. So when we were told that the snow, okay, but that's a Polish climate. I have one question to you, Andreas. When I was listening to, you just mentioned that string inverters in the utility scale especially will be more economic, and yes, and that's a strong point. Also, they are more stable for the grid parameters. Yeah, so they are more. You know, the first amusement of string inverters in the utility scale is now backing up. I believe that there is a return to the string inverter. Okay, the main advantage was that the string inverters can be easily removed and, you know, for servicing.
Yes.
Now the string inverters for utility scale, which I'm observing, are coming back. I would just like to ask you a question, Andreas, with regard to maintenance and service. How, from your experience, yeah, how would you prefer to have the maintenance done in the option of central inverter and the string inverters? And about the cost of maintenance as well.
But the cost of maintenance again is much cheaper with the multi-string inverters because, of course, any electrician can, even by himself mostly, take one inverter off and put it up again. The possibility of maintenance, again, if you lose one inverter, or let's say 10, we're talking about 60 to 600 or 100 to 1 megawatt, while a central grid inverter, of course, loses 1 to 2 megawatt.
Or to 5 even, or to 5.
Yeah, so, and that for days and sometimes months, especially now, I had a lot of problems in Greece and in Spain, as well in Italy, because that's all traditional PV markets. You don't get the spare parts anymore. So after 5 years, clearly it's very, very difficult to get the central grid inverter running again. Other inverter companies, of course, are they are maintenance free almost. Another problem, you always need a high voltage or a medium voltage guy with you, because it could be that you have to switch off the transformers, which some electricians are not allowed to do or have not papers for it. So again, to maintain a small 60 to 100 kilowatt inverter is much easier as a central grid inverter.
Yeah, SunGrow just announced 300 over 300 kilowatt string inverters. So there is a race, you know, in the amount of string inverters within 1 mega installed.
Yes, yeah, of course. I mean, you need 3 inverters only, and you have almost 900 1 megawatt. It's quite big. I mean, 1 megawatt is a lot of arrays connected to.
Sure. But my last quick question: if you will be having now a 100 megawatt farm, would you go the Chinese way still to put it with string inverters, or within such big utility scales, central inverters are more justified?
It depends actually more on the grid. If you have like a strong grid like in Germany, or like a weaker grid like in Netherlands, you tend to make smaller inverters. Like I said, it's easier to control, funny enough, as a central grid inverter, and the output can be marginally slowly get into the game. So when you install a multi-string inverters, you can, with clusters 110 megawatt, and already maintaining them and start producing energy, while with a megawatt inverter, maybe you cannot, because the field is not finished or something is missing, and then you cannot start it up. So it really depends on the local country and the transformer situation in this country.
Thank you, Mr. Darius, for your questions. Now we'll move to the Fathiya, if she is here. Is your name Fathiya, I think? She is not ready, maybe. We'll go to the Arnelito. Fathiya, are you there? Guys, we need at least to have your mic ready, either pressing the space, or you find out how to make your mic on. Here you go, Arnelito. Yes, we can hear you. Yeah, here you go.
I just saw some here. We have and we have 15 battery 250 ampere.
Sorry, we can't hear you very well, Marcus. Can you?
Hello, sir.
Yes, yes, now I can hear you.
I just repeat the question. Yeah, I have some question, and I have problem this 6 kilowatt solar power system, you have 16 pieces battery, 250 ampere hour, but the 3 pieces is now defective. Now the 250 amperes is available in the market. Can it change it in the 100 AH one time? The 16 pieces. Is there any problem?
From my side, I can't hear you very well, Marcus. Mr. Andreas, did you hear
Can
him?
you type the question maybe in the question answer section, because I really cannot follow.
Yeah.
very well.
Mr. Marcus, please write your questions in the question and answers, and I refer it to Mr. Iliou as soon as
I written it already, sir.
Okay.
I early.
You wrote it, huh?
Yes, yes.
Okay, I'll check it.
Somebody asked for the dust effect, so that's also something a lot of people are asking. Dust is nothing else than a shade, so it can affect quite dramatically. I had cases of 30, some 50, and some even 70% output not possible, so they had to be cleaned. So I don't know. It's really difficult to answer that question 100%, but I had some question like this before, and then they said the soiling factor was 1%, but when you go to the site, like I showed you the picture, that was 30% below the normal rated power output.
Yes, Mr. Iliou, there is a question from Mr. Marcos. He's saying that that he has a 6.2 kilowatt solar power system that has 16 pieces of modules and 12 volt 250 ampere hour battery in series connections.
Yes.
Connections. Is there any problem if he change it with a 200 ampere battery? Okay, I think he has 16 pieces of batteries.
Oh, okay. No, I mean, you can change, of course, the batteries. That's not an issue, but it depends on the output. I mean, there is a C value on the batteries, how much you should charge them. So, for example, the C10, so 250 amp hour battery, you can charge with like 25 amps. Just as an example, and then the battery will be full in this amount of time. It depends now if it's a 48 volt system or 12 volt system.
Hello, sir. That is 150 out. There is inverter grid tie.
Did you hear the question, Salem?
No, I can't hear him very well because the connection.
I just write it in message.
Yeah.
Okay. So like I said, I mean, I don't know why you want to change it to 200, but it is possible. It's like a truck battery. It depends on the output. If the output is very high, maybe you should add, I don't know, four batteries more. So you have 200 amp hours, but instead of 16, then you have 20 pieces of batteries. I cannot say, it depends on the voltage. Normally with 6.2 kilowatt, I expect a 48 volt system, but maybe it's 24 or maybe it's 12. When we talk about 1 kilowatt, 1000 watt, in a 12 volt system, we're talking about currents of 100 amp for a 1 kilowatt. If it's 24, it's 50, and if it's 48, it's only 20. So there you can see what's the difference and what's the amount of batteries are doing on your site. Sometimes it's a peak shaving, sometimes it's for the night time, or maybe it's an island system. it depends. For example, I buy 200 amp hour batteries personally when they're easy available. So if you get them easier and can replace them much quicker than 250 because you have to order them, then go for a 200 amp hour battery. Just add 4 or 8 batteries more. You will pay more or less, maybe the same, but it's maybe easier for you to get them. But sorry, I did not really understood the question.
Yeah, it's okay.
The problem is the 150 amperes is not available in the market.
Okay. I think he's saying that 250, it's a battery, 250 ampere hour, it's not available in the market. And,
yeah.
And he's planning to use the 200 ampere hour.
Yeah, go for the 200 amp hour. Maybe you have to use 2 setups or use some automatic changeover, and then you group them in 2 or something like that. But yeah, that's not a problem. I mean, everything is based on the inverters you're using. I used in Africa 200 and 120 amp hour batteries. They worked fine. Just because I got them there at the next fuel station. Let's say it like that.
Thank you, Mr. Marcus. Thank you. Thank you.
Thank you, sir.
Thank you. We'll go to the Fathiya if she is still there, or we can move to the another questions. Okay, we have Mr. Pere. Are you there, Mr. Pere Tamer? Mr. Tamer.
If nobody,
maybe they have problem to yeah, Miss Iman bin Arabia. If you are ready, you can.
Bin Arabia, yes.
Bin Arabia.
Hello.
hello.
Okay. Hello. Thank you very much, first of all, for this information session. It's really great. It's really. Am I audible?
Yes. Yeah.
Yes.
Okay, so it's really great to get in touch with experienced people. I have a question from the field. Well, I worked in a PV energy system. We planned around 40 PV panels. Well, the place were next to houses, to people houses. So once one of the people there, he told me that he's experiencing an electrostatic phenomena. So if he's touching anything with the iron or something, he told me that he gets electrostatic phenomena. Yes. So I'm asking if the PV installation is the one who's doing this electrostatic phenomena, or is there anything else? Thank you.
Yes, well, most possibly it's not like I said, the modules like in the early days in Germany, they just, like a lightning protection, they put the earth just down to the soil, and then they put an earth stick in. There was no return towards the inverter or towards the transformer. Of course, in a normal house, the transformer is far away, but normally the house gets an earth. So either the earth is connected up in the soil, and you should reverse at least to this earthing point, or go back towards the inverter. So you should always earth the inverter coming from the AC board and the modules coming from the rooftop, because some leakage and stray currents can go up to the roof, and then when you touch them, you have these phenomena of touch voltage. Of course, it can also be a faulty wiring of the DC side. So when the connectors are faulty, or when it's wet, or during morning dew, I don't know when he gets the shock, but if he gets the shock when it's wet, or like I said, he always gets the shock, then there is most probably a problem with the earthing at his house. So they forgot to earth something. So there is no return towards the inverter.
No. Okay, thank you, Ms. Iman. Now we have Sarah Rushed, if she is there.
Yes, hi, hello, good evening. Thank you so much for this webinar, Dr. Andreas and Engineer Salem. Thank you very much.
Thank you.
My question revolves around the design software for the solar system. I want to ask, so I know there are two popular designing softwares, which are the BV-Syst and the BV-Sol. I'm wondering if you can recommend which one's better for what kind of, which one is better, like in general. I know in Kuwait we use BV-Syst, like most companies, they use BV-Syst, but I'm curious about BV-Sol. Thank you.
Yes, on my standpoint, I like PV-Sol more because I grow up with it. But again, sometimes it's like Windows and Apple, right? So some people like Windows more than Apple, and some like Apple more than Windows. It's a preference. So when you feel good with either one of them, they're both good. I would not prefer one, but like I said, for me, it's easier to use PV-Sol because I use that from day one. But the other one is similar good. And you should also experiment with existing systems if the system is actually telling you the truth, whatever you install. I would say like that. It's a very good question.
Thank you. And Mr. Najib, are you there? We don't have a lot of time, so we have to move faster. Mr. Najib is not there. Let's try Mr. Majid. Are you there, Mr. Majid?
I have one question, if you like, I can read that. It's from Richard Musi. He's asking me, can you explain more about the Phantomizer cable faults you mentioned in the morning with condensation? My understanding is that cable resistance reduces with water presence, and therefore those phenomena, phantom warnings of the inverter, actually a sign of cable degradation. Yes and no. So again, the Phantomizer fault is a combination of modules, cabling, and inverter. So if the cables are quite long, if the modules exceed 50 square meter, there's a formula in my presentation which it shows you. So normally a panel has got 20 to 40 mega ohm and per square meter, and when you hook them up, it's the formula 1 to R. So if you have 20 modules hooked up together, the 20 or 40 mega ohms is soon going to be down to 667. So 50 square meter of surface of a module, which I said is like almost 20 modules, one string. If that's combined on a roof surface and it gets wet, that's already enough to go below 1 mega ohm. Most of the inverters have got now an override function, so they work till 250 kilo ohm normally. But the old settings were 1 mega ohm because they never reached that. So again, if you have a second and third string next to each other, which the big systems have, then you're above the 50 square meter threshold, and you have to make some tricks. The tricks are, as I said, as also the former colleague was asking, it's DC and AC together. So you have to earth the roof, the modules, the AC inverter, and the transformer, and the stand of the house together. If you don't do that, it will not engage. And again, it's got nothing to do with the modules, because if the modules are faulty, for example, a string or a connector, then always the same inverter will have this warning, this ISO fault, every morning, every night, or even the whole day. So it's very tricky to find that, but a Phantomizer fault means from 5, 6, or 10 inverters, they are randomly showing you this fault. So that means once they're online, they don't show you that fault anymore. That's a Phantomizer fault. So, and that's because of condensing water and over exceeding the 50 square meter threshold, which easily can be installed like that. And that's my so-called Phantomizer fault. If you have a real ISO fault, then it's always the same inverter, it's always the same string, and when you remove the string, the inverter will just stand up. But if you remove the string and the inverter does not stand up, that means again you have this Phantomizer fault. I hope this helps a little bit more, but you will see that.
And now we have Mr. Abdul Mun'am.
Hello everyone. Thank you so much for the webinar. It is a very interesting webinar. Mr. Andreas, my question is that I have read the on-grid inverters operate in power and reactive and active power control mode, the PQ control mode. On
Yes.
the other hand, the off-grid inverters, they are basically operating in a voltage and frequency control mode. Can you please elaborate on that? I am from the background of production and control, and that really concerns me. The on-grid inverters, how in which mode they are operating actually.
Sorry, to understand the question again, you have on and off-grid inverters, or?
Yeah, the on-grid inverters.
Okay, and you just want to have a reactive active power control.
Yeah, exactly.
And you're concerned about what, to have it or to not have it?
To have it.
Okay.
Do the on-grid inverters have that ability to be the reactive control, to be in the reactive control mode?
Yes, it's actually perfectly running. Most of the time when I do the troubleshooting, the first thing I'm going to do is activate this function and check the earthing. So what's happening is I'm checking the possibility of the wiring wrong dimensioned, or some problems from the facility. Maybe you have an industrial complex, I don't know, or maybe you go in hybrid mode with a diesel genset. And when you do that, you can see the problematic issue with the cabling. Most of the times people always think electric, but PV is a little bit different. So that means if you produce on site, it's got a different effect as you consume on site. So also some industrial complexes in Pakistan and in India and then some in Europe, when they use this mode, they had troubles with some settings. The problem is not the PV system doing the purpose. The problem is also that they use sometimes already capacitive banks. So I don't know exactly if you already use on your facility other capacitives. So the interaction of these two is a little bit lagging. So that means the existing structure of the industrial complex works slower than actually the one in inverter mode. So you can play with that and have a look. I actually made some systems in Pakistan with 0.85 and 0.9, and then they almost didn't use anymore the original capacity bank with the inverters. It's a much better load because you reduce the energy, and the inverter actually also does not produce the ohms production, so he's not pushing into the transformer, because the transformer has then only the capacitive load, the reactive load, instead of the ohms load. So if you are going both ways, you eliminate the blind load and the capacity inside your facility and the problematic behavior sometimes of your cable structures. So to make it in the inverter, in my opinion, is much better. But you have to fine tune. You have to start at 0.8 and then go up 8.5, 9, 9.5. So it takes a little bit longer. I mean, for me, it was like a week in one place.
Okay, thank you, Mr. Abdul Mun'am. I hope that answers your questions. We'll move. We have only 3 questions. We try to answer them. Mr. Abdul Razak, I hope you have your mic ready. Mr. Abdulrazak. We'll go to the Mr.
Yeah, do you hear me?
Yes, we have you.
Good evening, sir.
Good
Thank
evening.
you for
Hi.
this webinar, which will be very interesting to us. I have one question on the off-grid. As we know, the output of inverter three-phase without a neutral. How we deal with it neutral in this case? Can we connect the earthing cable as a neutral? Thank you.
Thank you. Did you get the questions, Mr. Iliou?
I'm just resuming. You said you have an inverter which is not using a neutral and you want to connect it anyway? Or
Yes, yeah. As we know, the output of inverter pure or not pure three-phase with harmonic, without
yes,
of course.
some inverter manufacturers, they don't mind, so they connect it like a pump. So you have three phases, and then you use the earth. You mean, right? So you use the earth as a
neutral.
Well, at the end it's the same, right? Sorry.
Can we connect the earth cable as a neutral?
Yes, you can, because you earth the transformers, right?
No, I have off-grid system without a transformer, not on a grid.
It's an off-grid system.
Yeah.
And what is it, single phase or three phase?
A three-phase, single phase without a problem. There is a neutral and the line. But in three-phase, as we know, the output of inverter, three-phase only. So if I, as I say, if I have a panel control, which needs a single phase, neutral and one of phases.
I mean, I don't know now the inverter specifications, but I know mostly only Victron Energy. So what they do in a hybrid mode, they actually engage the neutral and the earth inside the inverter when the power shuts off or when they're in island mode. So that means if you're in a hybrid mode and you're running with a system grid, running on an island, you combine the neutral to the earth. But now it depends on the manufacturer. Normally you should earth somehow the system, because otherwise you have a floating voltage. That's not so good. I had inverters in Africa where I had to ground the outside plug. So that means it's floating, so like 120 volt neutral and 120 volt phase, right? And then actually you used one of the phases, earthed it to the ground, and then you had 240 volt. But depends on the inside how the filters are connected to this. Some systems also earth the negative pole of the batteries. So maybe you ask the questions in the tutorial and tell me more about the inverter. Then maybe I know more. But normally there should be somehow a neutral or an earth connection towards this, because you use it in a single phase, right? I mean, three phases, or you use it for a pump.
Okay, thank you, Mr. Abdulrazak. Now we'll move to the Mr. Muhammad.
Okay.
Mr. Muhammad.
Hi, I'm Mr. Salem and Mr. Andreas.
Yes, we can.
Can you hear me?
Hi.
Okay, thank you for the very valuable webinar regard to the solar PV maintenance. I have two questions to ask. Can I know what is the allowable voltage ground fault at the DC side? And then what is the resistance?
Mr. Iliou, did you hear the questions?
There's a lot of background noise. Could you hear it better?
No, but I hear some noise. Mr. Muhammad, we cannot hear you very well. There is some.
Okay, sorry for that. Can you hear me clearly now?
lot of noise in the background. I don't know.
There is some noise. Sorry.
Okay, we try again. Hello?
Yes. Yes.
Can you hear me now?
Still like an echo or something.
Okay. I'm going to my account now. Okay, I'm leaving my account.
Can you type your questions, Mr. Muhammad?
Okay, can you hear me? Right?
There is a questions and answers text. You can
Okay.
type it because we need.
Okay, I will start with my Q&A.
Very difficult to understand, really.
Yeah. We have to move to another one. Mr. Iliou. Mr.
Hello, good evening.
Good evening. Hi.
Can you hear me clear?
Yes. Yeah. We need to speak louder if you can.
Yeah. Hello, sir.
Yes.
I
Hi.
just want to ask if what would happen because some of the inverter that I buy, they insist of installing new ground rod. No?
Okay.
They said that I need to borrow new ground rod, at least 2 feet or 3 feet rods. No? And I said to my technician, do not put any ground rod, just connect the ground to the main ground rod of the premises or the system ground to avoid the voltage step.
Yes.
If I follow the manufacturer's guideline to install ground rod.
Well, like you said, if you have an existing ground rod that is nearby,
Yeah, there is a existing electrical system.
it's always better to offer one grounding at all.
Yeah.
Maybe he thinks about the lightning protection. Maybe there is some SPDs inside or some.
No. The lightning protection and the is separate. We have a one ground.
Like you said, you have an existing ground rod. It's always better to use the.
Should I follow the manufacturer to install new ground rod, knowing that it will create a step voltage, or should I what you call this? Should I
How far is it away from the existing earthing system?
maybe around 5 meters or?
Or 5 meter. When we talk about 50 to 100 meter, it's debatable, but 5 meter means nothing.
So it's negligible. So I can use. I can.
Yes.
What is?
Yes, you can try to.
I can neglect the step voltage for that one for safety.
There is no possibility of step voltage. I mean, the inverter is grounded from the AC source already, and now you make a cable towards the.
No, the inverter have its own grounding because it says install a new ground rod for the inverter.
Yes, but you have an AC cable going to the inverter, right?
AC cable going to the inverter, yes.
Yeah, so you have already 3 wires or 5. So that means you have 3 phases or 1 phase, neutral, and an earth, right?
Yes.
Yeah, and then the second earth, you go towards the grounding transformer or AC board.
What I mean is from the inverter, there's
Yes.
a 5 cable from the main source, from the AC side.
Yes, but it's always advisable to come
from the inverter. It also have one ground rod going to the earth. So
yes, but it's like I said, it's enough to go to the existing ground rod. It's much better also for safety reasons to use the existing one, because otherwise you create more hazards than actually you help it.
Yeah, that's what I am.
So if they ask for a ground rod, because in America, for example, the inverters is far away from the meter, and then they want a ground rod next to the inverter because it's like 50 or 100 meters away. But if it's within 5-10 meters, and you have a ground rod, an existing one, it's the same. It's actually better.
So in setting like here in Saudi Arabia for the villas, I should not put new ground rod, or should I put?
Like I said, my advice is not when it's within 5 to 10 meters.
Okay, we have.
But you have to bring the cable back to the source and bring earth from the AC board, and then you are already double secure.
Thank you.
Thank you for your advice.
Thank you.
Question.
We have last 2 questions because we already took 1 hour more. Now, our friend Mr. Mohammed Faisal, he wrote his questions. He's saying, what is the allowable ground fault voltage leakage at DC site? And what is the good earth resistance value?
Okay, so so when we talk about the inverter and leakage, I'm always talking about AC current, of course. So when you ground it, it should be below 1 ohm. So from the inverter to the roof, and from the inverter to the soil or to the transformer, when you measure, it should be step touch voltage below 1 ohm. And when you have that, you will see the currents of the described inverter booklet. They tell you it's 60 amps, 60 milliamps, 80, 100, 300 milliamps, depending on the size. Normally 10 kilowatt is between 30 and 100 milliamps, and above 10 kilowatt, 25, 100 kilowatt, we're talking about 100 to 600 milliamps, possible going back to the soil. So now that's a similar question like the lady had with the shocking of the guy on the roof or on a ground-mounted system. That is potentially when the earth resistance is very high. So that's why I always say go to make a soil connection, but a normal earth rod, depending on the soil, sand, stones, clay, it's between 25 ohm to 100 ohm, and sometimes even more. This earth is completely useless. This is only going to help for a lightning strike that the surge arrestor ignites and it goes straight down to the soil. That has to be within 1 meter. But when we talk about high frequency noise, we talk about touch voltage from the frame, from the modules, it has to be below 1 ohm. So an earth rod, whether AC or DC, above 1 ohm is completely useless. It's not working. I don't know if you remember, Salem, when we did the tests on in Kuwait with the existing structure, and we doubled up the earth, and what leakage current happened actually when we doubled it up, although it was earthed already. It's sometimes 1 earth more changes the momentum of the installation. So because the higher the frequency, the less the possibility of that it actually gets grounded, because we have to get rid of this. Otherwise, also the output, the D-rate of the inverter will cause problems on your productions.
Okay, thank you, Mr. Iliou. We have last questions. She is with us, Ms. Marwa Mansour. Marwa Mansour.
Yes, Engineer Salem, thank you.
Thank you.
Do you hear me?
Yes.
That's very good.
Thank you for the Arab Council for Sustainable Energy for these fruitful lectures and webinars. And thank you, Mr. Iliou. And I have 2 questions. The first one, Mr. Iliou, can you tell us about the implementation of agro-photovoltaic and how efficient it can be used in our Arab countries? The second question, here in Egypt, we use the orientation of our solar cell in southwest, southeast. But you say that the east-west is better. Can you explain the difference and what is better? Thank you.
Okay, good. Very nice, the question. Very good. Well, in Germany, southwest, southeast, it depends, of course, where the country is and how the weather fluctuates. In Germany, we have a lot of fog and a lot of cloudy morning time, and normally after 10 o'clock, the power output is better in European countries as in the morning time. It could be that in Egypt, the east-facing system in the morning is more powerful than at night time. If you have like a self-consumption system, I always go east-west because you want to start very early in the morning to bring the energy in, want to stay as long as possible online. So again, like I said, in Germany, better to go east-west. Because you are in a self-consumption mode, you want to charge the batteries, for example, in hybrid. Now, the implementation of agrivoltaic, it depends on the sector. When you have countries like Germany or America, where you have a monoculture, of course, you can build, especially with bifacial, there is one system, I can give you the data for that. It has got two peaks. It stands up 90%, 90 degree. So that means you have southeast and southwest in a 90 degree angle. And so you actually create two different peaks, one in the morning and one at nighttime. And of course, on both sides of the system. And that's the best. So you have truck where you pull through the field, and you have the distance of the truck. You have one stand up on the left side and then one stand up on the right side. So, and then of course, you don't seal the area of land. So if you have big land available and you want to harvest energy and at the same time the wheat and some fruits, of course it's a good idea to implement both systems at the same time. I hope that helps a bit, but it's local based. So if you experience more power during east time, say southwest, then of course here in Cambodia, for example, south or north facing, east or west facing, if the angle is flat, it doesn't matter at all. The sun shifts in between south and north a few degrees. So if it's flat angled, the orientation almost makes no difference.
Okay. I hope that answers your question.
Okay, thank you. Thank you.
Thank you.
But here in Egypt, we change the orientation plus or minus 15 degrees from winter to summer.
Yes.
Plus or minus 15 degrees for the tilt angle.
Yeah.
Yes.
But I mean, I was in Benban. They use the trackers, so they're also tracking east-west. So that's another source where they do that. So I don't know. That would mean in the morning time they create more power than after 12 o'clock. Could be, but they take both angles.
Okay, thank you.
Thank you, Mr. Marwan.
Thanks a lot.
And that was the last question we have. And we almost took 4 hours from your time, Mr. Iliou. Thank you so much for your delivering the useful information from your highly experience. We appreciate that, and also we thank our friends who attend this workshop or training. We hope they enjoy the training and they get advantage of it. Thank you, Mr. Iliou.
Thanks for having me, Salem. Always a pleasure.
Thank you, and surely we will meet again sometimes. And please, guys, stay tuned with us through our LinkedIn or Twitter and Instagram for our upcoming events. We will have some interesting trainings and webinars. Thank you so much, guys, and we'll see you later. Bye-bye.
Thanks a lot.
Nice.